Hello, everybody. Mrs. B here. Today, our learning target is that we are going to talk about finding area of figures by composition or decomposition. So, a composite figure is a figure that can be separated into regions that are basic figures, such as triangles, rectangles, trapezoids, and circles. So, basically, it's like a couple shapes connected or a shape missing from a shape. So we'll look at some examples here. So first example here, find the area of the figure. So our first task with these is we're going to try to figure out how can we break up each of these shapes. So we want to look at this shape. We want to decide what is going to be the easiest way to kind of break it up. So you can see part of it is already kind of broken up. Over here, we have a half circle, and then we have this goofy shape here. So there's a couple of different ways that we can look at this shape. How I'm going to choose to look at it, though, is looking at it like it is a rectangle missing a triangle. So I'm just going to draw, pick a different color here, draw in here. So thinking about this big rectangle and then subtracting this little triangle. So I'll start with the semicircle. So if we know this whole side length is 8, that means that half of that is going to be 4. So my radius is equal to 4. So I know that the area of a circle is equal to pi r squared. So here we have pi r is 4. However, it's half of a circle. So I don't want the whole area of the circle. I want half of it. So pi times 16 over 2. 16 divided by 2 is 8. 8 times pi. 8 pi. Oh, wrong button. Sorry. There we go. 8 pi 25.1. So that's this first region here, this semicircle. So next, I'm going to find the area of this rectangle here. Pretend that those lines are real straight. All right, so I know that the area of a rectangle is base times height. Base here is 15. Height is 8. 15 times 8 is 120. All right, but I'm not quite done because again, I want to get rid of this triangle here, thinking about that original black shape. So this triangle here, I know that the area of a triangle is equal to 1/2 base times height. So I know that the base, if this is 8, this is also going to be 8. What I don't know is I don't know the height. So I need to figure out this height here. So there's a couple different ways that we can think about this. Number one, looking at this triangle here, I see that we have these tick marks also. So I know that all 3 sides are 8. This is an equilateral triangle. If we have an equilateral triangle and I'm drawing down the height here, that means that these 2 sides are going to be congruent, meaning that they have to be 4 each. So if I take this little triangle here, so I know it's a right triangle because I drew in the height. I know this is 4, this is 8. I can solve for the height using the Pythagorean theorem. So my hypotenuse is 8. 8 squared equals 4 squared plus h squared. 64 equals 16 plus h squared. subtract 16 from both sides. And I'm going to get 48. Take the square root of both sides. Square root 48 is 6.9. So now when I'm going back to my triangle here, 1/2, the base, again, thinking about this whole big triangle, my base is 8, and the height is 6.9. So then if I go to my calculator, 1/2 times 8 times that answer, that previous answer, and I get 27.7. All right, so now I know the area of all, excuse me, the pieces. So now I need to figure out, again, that original black area. So we talked about how it was a semicircle, adding it to a rectangle, but then subtracting off the triangle. So I want to take 25.1. I want to add on the rectangle, but subtract the triangle. Whoa. So 25.1 plus 120 minus 27.7 equals 117.4. And our units, want to make sure we have units, centimeters. We're talking about area, so centimeters squared. All right, so kind of a lot of work to go into one problem, but you have all the tools to do this. So let's look at another example here. So find the area of the figure below. So again, the first thing we have to decide is how to break it up. This one's kind of nice because it's already pretty broken up. So we know we have 3 distinct shapes here that we are going to find the area of. We have a rectangle here, we have another rectangle here, and then here we have a quarter circle. So I'll just start at the top here, finding the area first of this rectangle. So again, I know the area of a rectangle is base times height. Base 3.5, height is 3. 3.5 times 3, 10.5. All right, next, find the area of this quarter circle. So if this is 3.5, that also means that this has to be 3.5 because it is the same measure just being kind of dragged down. So that is my radius. So the area of a circle, pi r squared. So pi radius 3.5. But again, just like the last one, it's not a whole circle, it's a quarter circle. So I want to divide that by 4. So 3.5 divided by 4, and then multiply that by pi 3 up times, there we go, 3.5 divided by 4, 2.7. And then lastly, we have this rectangle here. So again, we know that the area of a rectangle is base times height. So 5.5. And then again, the radius of a circle is consistent throughout the circle. So if this radius is 3.5, that means that this radius also needs to be 3.5. So our height of our rectangle is going to be 3.5. So 5.5 times 3.5, 19.25. Now to find the area, this time we're just adding all of these together. We didn't do any subtraction at all. We didn't have to subtract off any shapes. So we're just going to do 10.5 plus 2.7 plus 19.25 to get whole area. We get 32.45. Again, units, millimeters squared. All right, let's look at one last one. All right, so this one, very, very similar to the first one that we did. But if you remember that one, we had a semicircle, we were subtracting a triangle. But when I'm looking at this, I'm seeing we can take our rectangle here. So I'm gonna separate this here. And I see three distinct shapes. I see a triangle, I see a rectangle, and I see a semicircle. So this is the same type question as we saw before. So if I'll start with the triangle here. So this one is similar to the one that we did before. If I know this is 10, I know this is 10 also. Area of a triangle is 1/2 base times height, but again, I don't have the height. I'm going to draw that in. But again, I can think about this as right triangle doing the Pythagorean theorem. If this is 9, this is also 9 because of those little tick marks there. So again, this is an isosceles triangle, which tells us that these two segments are going to be congruent, meaning that we have 5 and 5. So if I pull out that right triangle there, got 9 solving for h and 5, we can use the Pythagorean theorem. 9 squared equals 5 squared plus h squared. 81 equals 25 plus h squared. Subtract 25 from both sides. And I get 56 equals h squared. Take the square root. H equals square root of 56, 7.5. So now I can go back to my formula. 1/2, again, the base of the whole big triangle now is 10. The height, 7.5. Can go to my calculator. 1/2 times 10 times my previous answer, 37.4. Right, then I'm going to go ahead and find this rectangle here. Thankfully, this one will be a lot less work. Area of a rectangle is base times height. Base is 13, height is 10, so 130. But now I don't want the whole rectangle. I need to get rid of this half circle. So again, this 10 is the diameter, meaning that the radius is going to be 5. So the area of a circle is pi r squared. Pi r is 5, but again, I only want half of it. So pi times 25 over 2. $39.3. All right, so I found my 3 different areas. So what I need to do now is I need to add the triangle plus the rectangle, but subtract off the half circle. So 37.4 plus 130 minus 39.3. 37.4 plus 130 minus 39.3, 28.1. And those are meters squared. So on your homework assignment, you're going to see a lot of goofy shapes, but just keep in mind that all of these shapes can be broken up into shapes that you know how to find the area. So the key here is trying to figure out what kind of shapes you're adding together or what you need to subtract off. But once you do that, it'll just be the basic area formulas that we've already talked about this unit. All right, good luck with your homework and let your teacher know if you have any questions.